Okay guys, we want to try to do this remote learning. Today we're going to learn special right triangles. We're going to start with the 45, 45, 90 triangle. Okay? If I have a 45, 45, 90 triangle, what type of triangle is that? Yes, isosceles triangle. So we know those two are the same. They are congruent. Let's call that A and A. The 45, 45, 90 triangle ratio will always be A radical 2. Okay, that will always work. Let me show you an example using Pythagorean theorem. Call this 5 and 5. That will be my x. 5 squared plus 5 squared is x squared. 25 plus 25 is x squared. X is the square root of 50, which is 25 times 2, 5 radical 2. See, it will work throughout any of them. You may remember we talked about this maybe a week or so ago, previewing it. Now let's see if I went like this. If I call this 11 radical 2, what would x be? Well, if a radical 2 is 11 radical 2, x is just 11. Let's do something a little bit more, not complicated, but a little bit more to it, okay? The hair is tragic, I know, just excuse it. We're all just trying to make it through. Here's my 45, 45, 90 triangle. Let's call this 12, and we're going to solve for x here. What I like to do, and it'll make a lot more sense when we do 30, 60, 90 triangles, but I'll just label the sides on the inside. We know this is A radical 2. The goal is to find what is A. I don't have A here or A here, but I know that A radical 2 is equal to 12. Solve this out, divide both sides by 2. I can't have a radical in the denominator, so I'm going to rationalize it. So therefore A is 12 radical 2 over 2. This reduces out. A is 6 radical 2. And they're both 6 radical 2. Okay, I'm going to give you a break, take a second, listen to some Anthony Hamilton, then I'm going to come back with the 30, 60, 90 triangles. These notes are also in your packet that I gave you before we left and which are available on course pages.